Good morning. My name is Charlie Baum, and we're going to continue our discussion of production by looking at the long run. Let me remind you that there's two kinds of inputs, fixed inputs and variable inputs. Variable inputs can change, and they increase output if we use more of them. Fixed inputs, by definition, are fixed and don't change. In the short run, some inputs are fixed and some inputs are variable. In the long run, all inputs are variable. In the prior lecture, we looked at a production process and its corresponding cost structure for the short run. We knew that that was an example of the short run because some of the inputs were fixed. The input in particular that was fixed were ovens. So the cost curves we developed in the last lecture were for the short run. Now we're going to develop long run cost curves. One of the most important long-run cost curves is the long-run average cost curve. This is going to show us the lowest cost way of producing output in the long run. And keep in mind, in this cost structure, all inputs are variable. Let's start by trying to make the link between the short run and the long run. I'm going to show you two short-run cost curves. One for a small factory that makes automobiles, and one for a larger factory that makes automobiles. These are going to represent different scales of production. Perhaps the automobile production process uses two inputs, labor and factories. In the short run, labor might be variable, but factories might be fixed. If that's the case, then in the short run, the firm is going to find itself stuck on one of these scales of production. The factory is going to be a fixed input, and the firm can't change the size of the factory that it uses in the short run, so it will have to increase or decrease output by sliding along the cost curve for that short run production process by increasing or decreasing the quantity of the variable input used. In the long run, however, all inputs become variable, and so it's possible for the firm to change the quantity of its fixed input, of the inputs that had been fixed in the short run. In this example, that would mean it's possible in the long run for the firm to move from one factory size to another factory size. If the firm were to move from the small factory to the larger factory, then this would show us that the average total cost of producing these units of output would be going down. Economies of scale is present when the long run average cost curve is going down. In this case, you can see that in the long run, the average cost of production would be going down as we increase more output from 2,000 vehicles to 200,000 vehicles. And so in this region, the production process would exhibit economies of scale. That means we could double the output and the average cost of production would less than double, and so the average cost of production would go down. I'm sorry, let me say that again. If we double output, the total cost of production will less than double, so the average cost of production will go down. Let's add a few more factory sizes to our production process. Let's suppose that there is another factory size that corresponds with producing that corresponds with an even larger factory size. Now you'll notice that here the average cost of production looks like it has begun to go up. When the average cost of production is when the long run average cost of production begins to go up, this is when we're going to be experiencing diseconomies of scale. Now, the minimum efficient scale of production is going to be that scale where production occurs at minimum long run average cost. So we can identify the minimum efficient scale of production in this diagram by recognizing that the lowest possible long-run average cost of production is $27,000 per vehicle, and it occurs in a region, in a range between about 200,000 and 400,000 cars. During this production region, the long run average cost of production is constant. And so that means that we're experiencing constant returns to scale. If we double our output, the total cost of production will exactly double, and this means the long run average cost of production will stay constant. So we experience economies of scale and increasing returns to scale when long run average costs are going down, and we experience diseconomies of scale or decreasing returns to scale when long run average costs are going up. So in this diagram I have shown you 4 different factory scale sizes. And the long run average cost curve is designed to identify the lowest possible cost, lowest possible average cost of producing each quantity of output. What the long run average cost curve does is it essentially outlines the lowest possible point on all of these short run average total cost curves. So what I've outlined in red is really would be the long run average cost curve if these were the only 4 factory sizes that were available. Again, the red curve would identify the lowest possible cost of producing any of these levels of output. But in the real world, there are more than 4 factory sizes. There might be a small dash medium factory size, or a small dash medium factory size, or a factory size right in here, or a factory size right in here. When you add a lot of different factory sizes to the production process, it creates a long run average cost curve that is really U-shaped and isn't cupped in around the short run average cost curves as it would be if there were only 4 factory sizes. And so here you see the long run average cost curve, and it identifies the lowest average cost of producing each level of output, and here it's sort of assuming that there are actually factory sizes that are not really drawn so that you get a continuous long run average cost curve that looks like a saucer.